AI/ML model, K-fold cross-validation. The K-fold cross-validation video illustrates how a dataset is systematically split into training and validation sets across multiple folds. Each formula and mathematical branch, like calculus, trigonometry, algebra, etc., represents a data point with semantic or domain relevance, which makes this visualization not only functional but educational. Pradeep K. Suri, author, researcher, and AI/ML architect. Book's explanation of K-fold cross-validation, K equals 5. K-fold cross-validation is a technique in supervised learning where the dataset is divided into K equal parts, called folds. The model is trained K times, each time using a different fold as the validation set and the remaining K1 folds as the training set. This process ensures that every data point is used for both training and validation, improving generalization and reducing bias. Magnifying glass tilted left interpretation of the graph. The y-axis represents the fold number, 0 to 4. The x-axis is the data point index, 1 to 10. Each formula displayed is a math equation associated with a branch like E equals mc caret 2 rightward arrow physics. Indefinite integral f, x, dx rightward arrow calculus. A superscript 2 plus b superscript 2 equals c superscript 2 rightward arrow geometry. Color lines, vibrant, distinguish each fold and its role. Solid lines, training data. Dashed lines, validation data. Hover text shows the math formula and its branch. Factory K-fold in different domains. Domain use of K-fold cross-validation example. Education predicting student performance or exam outcomes using learning features branches of math used as features to classify student strengths. Healthcare risk prediction models, example stroke, diabetes, heart conditions, each data point may represent patient vitals or test results. Manufacturing predicting equipment failure or product quality based on process parameters data points could be sensor readings, machine hours, etc. Finance credit scoring, fraud detection, and loan default prediction data points may be financial ratios, transaction records. Retail demand forecasting or customer churn prediction data points represent purchase history, customer profiles. Physics/engineering forecasting outcomes of simulations, energy loss, or material durability use formulas like F equals ma, indefinite integral f, x, dx, etc., as input features or explanations. AI/ML model training evaluating model generalization before deployment ensures model is not overfitting, applicable across NLP, CV, structured data problems. White heavy checkmark why K-fold matters. Reduces variance from random train test splits. Improves model robustness. Allows fair comparison across models or hyperparameters. Suitable for small to medium-sized data sets. Brain AI insight, from visualization. This diagram, annotated with math formulas and branches, demonstrates an AI model's ability to process mathematical reasoning across domains. Apply fold-based validation for knowledge segmentation. Train on abstract symbolic reasoning patterns in education or STEM AI models. Example, AI/ML model training. Brain explanation of the K-fold dashboard image, AI/ML model training dashboard. The dashboard is a well-structured visual summary of key performance metrics during AI/ML model training using K-fold cross-validation, presented in a single screen using Plotly and Dash. Here's the detailed interpretation of each graph. Small blue diamond 1. Loss vs epochs, top left panel. Purpose, shows how the model's loss function value decreases with training over time, epochs. Chart decreasing loss is decreasing steadily, which is a good sign. Each fold in K-fold would train a model and this plot could be averaged across folds. Indicates model convergence. Small blue diamond 2. Accuracy vs epochs, top center panel. Purpose, displays the model's prediction accuracy across training epochs. Chart increasing accuracy improves over time, showing the model is learning patterns effectively. In K-fold training, this graph is useful to compare fold-wise accuracy progression or aggregate mean accuracy. Small blue diamond 3. Confusion matrix, Top right panel. Purpose, visualizes classification results comparing predicted vs actual labels. Heat map cells show true positives, true negatives, and false negatives. Can be created per fold to assess model consistency across splits. Bright yellow in the top left and purple in bottom left suggests class imbalance or prediction skew in some folds. Small blue diamond 4. Feature importance, bottom left panel. Purpose, ranks input features by how much they contribute to the model's decisions. Features with higher bars are more influential. Useful during each fold to validate whether important features remain consistent. Helps in feature selection or dimensionality reduction analysis during k-fold iterations. Small blue diamond 5. Rock curve, bottom center and right panel. Purpose, evaluates the classifier's ability to distinguish between classes. The magenta line is the true rock, the dashed line is a random guess baseline. The AUC, area under the curve, equals 0.57 implies a weak model, ideal is close to 1. This should ideally be computed per fold, then averaged for robust assessment. Puzzle piece role of k-fold cross-validation behind the scenes. K-fold splits the data into k-folds and performs training k times. Each time, one fold is held out for validation, while the rest are used for training. Metrics like loss, accuracy, AUC, and confusion matrix are gathered for each fold. The graphs shown represent either final fold results or aggregated results. Pushpin summary for AI/ML practitioners. Graph purpose. Loss vs epochs monitor training stability and convergence. Accuracy vs epochs track model learning progress. Confusion matrix inspect class-wise performance. Feature importance identify influential features. Rock curve, AUC, evaluate binary classification effectiveness. Integration with k-fold all metrics ideally tracked per fold and then averaged for insights. Thank you.